In an ideal Rankine refrigeration cycle, we know the input data for the devices. What is the coefficient of performance? 1. What is the coefficient of performance? 2. In Thermonator, we configure a control volume exercise because the substance enters and exits the devices. We select the sign convention to consider the work generated by the system as positive. We also configure power units because mass has units of time. We could create the cycle quickly using the New Cycle menu, but in this exercise, we will create the processes one by one. We enter the pressure and vapor quality entering the compressor and calculate the state with those properties. The compressor performs an adiabatic process, so we create an adiabatic process. By selecting the Calculations menu, we see the equations used to calculate all the states and processes. We enter the condenser inlet pressure and calculate the state at this pressure and the entropy of the adiabatic process. The condenser undergoes an isobaric process, so we create an isobaric process. We enter the steam quality at the expansion valve inlet and calculate the state at the steam quality and pressure for the isobaric process. The expansion valve undergoes an isenthalpic process, so we create an isenthalpic process. We enter the evaporator inlet pressure and calculate the state at this pressure and the enthalpy of the isenthalpic process. The evaporator undergoes an isobaric process, so we create an isobaric process. We select the Close Cycle menu and drag state 5 onto state 1 to close the cycle. We select the Zoom menu to adjust the graph. The solution is an operational efficiency coefficient 1 of 4.58 and an operational efficiency coefficient 2 of 3.58. How did we perform the calculations? By clicking the Information button, we can see the efficiency calculations. The operational efficiency coefficients are calculated by dividing the benefit by the cost of that benefit. The operational efficiency coefficient, 1, represents operation as a heat pump. That is, the benefit is the heat released by the condenser, Q23, and the cost is the work consumed, W2. The operational efficiency coefficient, 2, represents operation as a refrigerator. That is, the benefit is the heat absorbed by the evaporator, Q4, and the cost is the work consumed, W2. If you enjoyed this exercise, give it a like and share it with your friends.